Now please tell me, can you see the screen?
Yes, miss.
Yes, ma'am.
Okay. Actually, there was a problem with in my network. That's why a little delay today. Okay. There was a problem in the network. So today we will do higher order partial derivatives. Higher order partial derivatives. So suppose that f of xy is a function of x and y. F of xy is a function of x and y since the partial derivatives del f by del x and del f by del y are also functions of x and y. Definitely, if f is a function of x and y, if you perform this partial differentiation with respect to x, it will be again a function of x and y, and del f by del y, it may be a function of xy again. So these functions may themselves have partial derivatives. Yes, these two functions may have again partial derivatives. Okay, so so we can perform, if you perform a partial differentiation of this one with respect to x, so it will be second order partial derivative of f with respect to x. And if you perform the partial differentiation of this function del f by del x with respect to y, then it will be a second order partial differentiation, at first with respect to x and then with respect to y. So there may be a number of partial higher order partial differentiation. Actually, at first we are considering the second order partial derivatives. Actually, there are four types of partial differentiation. You see, del square f by del x square. That means it is a partial second order partial derivative of f with respect to x square, just like ordinary differentiation. Do you remember d square y by dx square? Do you remember what does it mean? D square y by dx square. D square y by dx square means it is the derivative of y with respect to x twice, isn't it? Would you
Yes,
remember? Just like this ordinary differentiation here also. So this second order partial derivative with respect to x, it means del x of del f by del x. That means at first you perform this first order differentiation, then again you differentiate it partially with respect to x. So this is a notation, and there is another notation. You can write it like this. If you perform the only the first order, then it was what? Fx, just fx. And again, if you perform the partial differentiation with respect to x, it will be fxx. So similarly, del square f by del y square, it will be del y of del f by del y. That means second order partial differentiation with respect to y. So this is a notation, and this is another notation, fyy. Now, if it is like that, at first with respect to x, then with respect to y. So here it will be like this. Del square f by del y del x. It means del y of del f by del x. So please try to understand, please try to perform the notations. If the notation is this, that means at first you have to differentiate with respect to x, then with respect to y. So it will be del y of del f by del x. But when you denote this second order with in terms of this f, at first it was fx, then with respect to y. So fxy. So here, differentiate first with respect to x, then with respect to y. Here you see, at first, it comes from the right to the left. If you denote it like this, del square f by del y del x, at first start from the right, then to the left. But if the notation is this way, then at first you have to start from the left, then to the right. So these notations should be very clear with you. Otherwise, your math may be wrong. So what is it here? Del square f by del x del y. That means at at first you have to start from the right. So at first you have to perform the differentiation with respect to y. So del f by del y. This is done first, and then you differentiate again this function with respect to x. So this del x goes to the left and this del y to the right. But when you write it with the subscript to this f, you say at first fy, then x. So it will be f of yx. So you see fxy and fyx. What is the difference in between these two? Here at first you have to perform the differentiation with respect to x, then with respect to y. And here at first with respect to y, then with respect to x. So this is important when you perform your partial differentiation. The last two cases are called the mixed second order. Why mixed? Because these differentiation are done once with x with respect to x and then with respect to y, or at first with respect to y, then with respect to x. So this is known as mixed second order partial derivatives or the mixed second partials. Okay, we observed the two notations for the mixed partials have opposite conventions. Yes, it is opposite conventions because here, if you use this notation at first with respect to x, then with respect to I, from the right to the left, and here from the left to the right. So this is in opposite conventions. So please try to memorize it. These conventions are logical if you insert parentheses. Yes, parentheses. So del square f by del y del x, it means del y of del f by del x. And if you use this notation, it means at first you have to differentiate this fx with respect to y. So here left to the right, and here right to the left. Okay, equality of these mixed partials. Mixed partials means fxy and fyx. Let f of x be the second order partial derivative in some domain, in some range. Then if these two are continuous in some domain, then these two will be equal. But if these two are not continuous, in that case they will not be equal. So it follows from this theorem that if these two derivatives are continuous everywhere for all values of x, then this partial derivative will be equal to this. It is if xy and it is y if yx will be equal for all values of x and y. Okay, now you can perform third order, fourth order, and higher order partial derivatives in the similar way. So del cube f by del x cube, what it will be? It means it is the third order partial derivative of f with respect to x. So at first, okay, I'm sorry. Um, it should be, there cannot be any square here. So it is actually, we know what does it mean. We know, by now we know what is del square f by del x square. It means f xx, and it is the partial second order partial derivative of f with respect to x. So there cannot be any 2 here. So please cancel these two. It will be simply del x because it is of third order. So at first it was second order, then with respect to x. So in total there will be third order, and in this with the subscript notation it will be fxxx. And what will be del 4f by del y to the power 4? It will be del y. It is correct now. Del y of del cube f by del y cube. And this is the notation with the subscripts 4y, because all the partial derivatives are done with respect to y. And what about this one? You see del cube f. That means it is a third order partial differentiation. And at first, in this notation, you have to come from the right to the left. So at first with respect to x, then with respect to y twice. Then with respect to y twice. So by now we know what does it mean. Del square f by del y del x. It means at first with respect to x, then with respect to y, and then again with respect to y. So ultimately it becomes third order. And with this subscript notation, it will be at first x, yes, from the left to the right. At first x, then y, then y. Okay, now look into this. It is fourth order differentiation. So del y of del cube f by del y del x square. That means at first with respect to x twice. Yes. with the subscript notation with respect to x twice, then with respect to y twice. So f x x y y. So these are some examples of the notations for higher order partial derivatives. Now let us do some problem here. Suppose your function is this, z equal to root over x into y. Then you have to perform this differentiation. This is second order with respect to x. This is second order with respect to y. This is second order with respect to x, then with respect to y. And here, again second order, but here at first with respect to y, then with respect to x. So here, this is the beginning. So I'm showing you all the derivatives. Oh, your computer needs restarting. So will you please excuse me for 1 or 2 minutes because the computer needs restarting. I have to restart now. Just a minute.
Okay, miss. Okay,
Okay,
ma'am.
just wait for a few minutes. Na? Restart now.
Miss, you are muted.
Can you see the screen?
Yes, Miss.
Yes, Miss.
Higher order partial derivatives, can you see the screen?
Yes, Miss.
Okay.
Yes, ma'am.
So now, sorry for the disturbance, but it needs restarting. So we started the math here. We started the math here, z equal to root over x into cos y. So at first we perform del z by del x for this number 1. So del z by del x means del x of this, del x of this. So this factor cos y does not contain any x, so you can take it as a constant factor outside this partial derivative. So cos y into del x of root over x, and del x of root over x is 1 by 2 into root over x into cos y. So now the, okay, again you can write it here d dx because there is no y here. Now the second order derivative, so you have to differentiate this del z by del x again with respect to x. So it should be del x of this thing, del x of this thing. So again you can take half cos y outside the partial derivative. So it will be cos y by 2 into d dx of 1 over root over x, and 1 by root over x will give you this minus half. 1 by root over x means the power is minus half, so it will be minus half into x to the power minus half minus 1. That means it will be minus 3 by 2. So this gives you the result. Now you have to perform del square z by del y square. So at first we perform the differentiation with respect to y. So in this case root over x is constant. So let us take it outside the differentiation, and cos y, del y of cos y will be minus sin y. So it will be minus root over x sin y. And now find the second order partial differentiation. So it will be del y of del z by del y. That means del y of this thing. So you can take again minus root over x outside, and the derivative of sin y with respect to y is cos y. So this is minus root over x into cos y. Now remains the mixed partial derivatives with respect to x and with respect to y. So it is a number 3. So here at first we perform the differentiation with respect to x. So it was what? 1 by 2 into root over x into cos y. We have already done it. Now you have to differentiate this del z by del x now with respect to y. So it will be del y of this thing. So here 1 by 2 into root over x is constant, and derivative of cos y is minus sin y. So it will be minus 1 by 2 into root over x into sin y. Now let us perform what? Del square z by del x del y. So at first we have to find the derivative with respect to y. Yes, we have already found it. It is minus root over x sin y. Now with respect to x, so it will be del x of del z by del y. So del x of this thing. So minus sin y can be taken outside, and del x of root over x is 1 by 2 into root over x. So this is the result. And here you see both the mixed partial derivatives are same. So here these two functions are, these partial derivatives are continuous everywhere except at x equal to 0. At x equal to 0 it is not defined, except at x equal to 0 these two partial derivatives are continuous everywhere. You see, that's why these two are same. Now the next question, verify that these two mixed second order partial derivatives are equal. This is equal to this. So there are three maths. I will show you the first one and the second one. U of xy equal to ln of x square plus y square. So let us start with this ln of x square plus y square. So at first we will perform del u by del x. That means del x of ln of this. So you have to consider this whole x square plus y square as single x because your partial derivative is with respect to x. So ln of x gives you what? 1 over x. That means 1 by x square plus y square. Now, this is not simple x. It is x square plus y square. So you have to perform the differentiation of this whole thing with respect to x. Partially, of course, partially. So 1 over x square plus y square into del x of x square plus y square. There are two terms, addition of two terms. So the second term, in the second term there is no x, so the derivative of this term will be 0 and the derivative of the first term will be 2x. So ultimately it will be equal to 2x divided by x square plus y square. Now we will perform the differentiation with respect to y. So del square u by del y del x, it will be del y of del u by del x. So that means del y of this thing. Del y of this thing. So now the differentiation is with respect to y. So you can take this 2x outside. So 2x into so disturbing sound. Let me change my position. Okay, let me change my position. এই বাসাটা so here del square u by del y del x. So we have to find what del y of del u by del x. And here, now you are performing the differentiation with respect to y. So this 2x can be taken outside the differentiation. So it will be 2x into del y of 1 over x square plus y square. Now it is with respect to y. So this lower part should be considered as a single y because this partial derivative is with respect to y. So if it is 1 over y, what is the differentiation? Del y of 1 over y, that means y to the power minus 1. So it will be minus 1 into y to the power minus 2. Minus 1 into y to the power minus 2, and your y is this x square plus y square. So it will be 2x into minus 1 into this whole to the power minus 2. But this is not simply y, it is x square plus y square. So you have to perform the differentiation again of this x square plus y square with respect to y. So now it gives you what? X square is constant because your differentiation is with respect to y. So this x square is constant, it gives you 0, and the partial derivative, the whole thing will be just 2y. So at first it was minus 2x into 2y, it will be minus 4xy, and in the lower part it will be x square plus y square whole square. Definitely x cannot be equal to 0, y cannot be equal to 0, because here if x equal to 0, y equal to 0, the whole thing becomes undefined. In the original function also you see when x equal to 0, y equal to 0, it becomes a ln of 0. And do you know ln of 0 is undefined, it is infinity. So here this is square, this is square, so there is no problem if x is negative, y is negative, no problem because they are square. But if x equal to 0, y equal to 0, the argument becomes 0 and ln of 0 is undefined. Do you know what is the value of ln of -1, ln of any negative number?
Is
Anybody can tell
undefined.
me?
Undefined.
Undefined, right. It starts from 0. Ln of 0 is undefined and ln of any negative number is also undefined. So this is called the argument for logarithm of any variable. The whole thing must be greater than 0, even not equal to 0. Okay, so remember here x cannot be 0, y cannot be 0. Now, this is the expression for the differentiation mixed partial derivatives del square u by del y del x. Now we will find del square u by del x del y. So for del x del y, at first we have to find the differentiation with respect to y. So del y of this thing. So as before, it will be 1 over x square plus y square into del y of this thing. So now it gives you 2y by this. Okay, so again you have to perform the differentiation partially with respect to x. So now it will be del square u by del x del y. So del x of del u by del y. That means del x of this whole thing. So now 2y is a constant, so you can take it outside the differentiation. So it will be del x of this. 1 over x square plus y square means x square plus y square whole to the power minus 1. So as before, it will be minus 1. You have to consider this whole thing as a single x because your derivative is to be performed with respect to x. So consider this whole thing is as x, so x to the power minus 1. So it will be minus 1, this whole thing, whole to the power minus 2. And then again, you have to differentiate partially this whole thing with respect to x. So del x of x square plus y square, which gives you just 2x. So 2x into minus 2y, it will be minus 4xy. And here comes the lower part like this, x square plus y square whole square. Here again, x not equal to 0, y not equal to 0. And you see, the two expressions are exactly same. Here it was minus 4xy by x square plus y square whole square. And here also the same thing, minus 4x square xy divided by x square plus y square whole square. So these two are same. So let us do the same thing for this function, sine inverse x by y. So at first we perform the differentiation with respect to y. Del u by del y. So del y of sine inverse x by y. So you know what is the derivative of sine inverse x with respect to x? Please tell me. Sine inverse x.
Is
1
1 by sec square or something.
Is
over
1 by square root of 1 minus u, u square
1
by x
minus
square.
x. Right, very good. So here you have to consider this x over y as what? As what?
As x, মানে x over y কে x দ্বারা বসো।
As x.
As x or y. It is a
y
differentiation with respect to
নিচে
y.
y আছে, so
So
y
yeah, you have to consider this x over y as y, not x, because your differentiation is with respect to x, y, sorry. Your differentiation is with respect to y. That's why this whole thing, x over y, should be considered as a single y. So what will be the derivative of sine inverse y? It will be 1 over root over 1 minus y square, and your y means x over y. So it will be 1 minus x square by y square. Now, this is not simply y, it is x by y. So again, you have to multiply this whole thing by what? Del y of this x over y. Do you understand? Del y of x over y. Now it is a partial differentiation with respect to y, so this x can be taken outside. So you do this algebra, under the square root it will be y square minus x square divided by root over y square, and root over y square is y. So this y can be taken to the upper side, and here you are taking this x outside the derivative because the derivative is to be performed with respect to y. So del y of 1 over y, and it is simply minus 1 by y square. So what you are getting in the upper side, it is x into y. So one y can be cancelled out. So it should be like this, minus x by y into 1 over root over y square minus x square. So this is the expression for del u by del y. Now we will find the second order derivative. Again, you have to differentiate this del u by del y with respect to x. So it will be del square u by del x del y. What was our del u by del y? This was this minus x by over y into 1 by root over y square minus y square x square. So you have to perform the partial differentiation of this with respect to x. So you see here 1 over y is constant factor. So it can be separated from this x. So that's why you can take this 1 minus 1 over y outside the derivative. So it will be minus 1 by y del x of x divided by root over y square minus y square. So you see the upper part contains x and the lower part also contains x. But this x cannot be separated from this y because this whole thing is under the square root. So you have to perform the differentiation in the taking it in the quotient form, u by v form. U by v form. So let us keep this minus 1 over y outside this third bracket and perform it. U by y, or okay, I have performed it like this: u into v, u into v. Your u is x and v is 1 by root over y square minus x square. It is up to you. Either you can consider it as u into v form or u by v form. Ultimately, it will give you the same result. So here 1 over 1 by root over y square minus x square into del x of this. Okay, then plus x into del x of 1 by root over y square minus x square. So del x of x is simply 1, so it will be 1 by root over y square minus x square, and here x into del x of this. So here this whole thing y square minus x square should be treated as single x because your partial derivative is with respect to x. So del x of 1 by root over x. 1 by root over x means x to the power minus half. So it should be minus half into this is your x, x to the power minus half minus 1. That means minus 3 by 2. So again, this is not simply x, it is y square minus x square. So you have to perform the differentiation again for this y square minus x square with respect to x. So this whole thing into del x of this. So 1 by root over y square minus x square, and here this part will give you minus 2x because y square is constant. Del x of this whole thing will be minus 2x. These two and these two cancel out. This minus, okay, this minus, and there is a minus sign. So ultimately it will give you plus sign. So this x and this x gives you x square, and in the denominator this power to the power 3 by 2. So if you take the LCM of these two terms, LCM will be y square minus y square whole to the power 3 by 2. And here if you divide this one by this, there will be only y square minus x square whole to the power 1. So y square minus x square, and here remains 1 x square. So these two cancel out. So this y square and this y. 1 y will be cancelled. So the result will be minus y divided by y square minus x square whole to the power 3 by 2. So this is the result of this second order partial derivative, del square u by del x into del y. Okay. Now you have to find del square u by del y del x. This is the result of del square u by del x del y. Now you have to find this. So as before, you find del u by del x. So del x of this sine inverse x by y. Here this x by y should be considered as single x. So sine inverse x will give you 1 by root over 1 minus x square. That means 1 by root over 1 minus x square by y square into del x of x by y. Here 1 over y can be taken outside. Yes, 1 over y outside, and this gives you y divided by root over y square minus x square, and del x of x is simply 1. So this y and this y cancel out, so it is this 1 by root over y square minus x square. Now you have to perform the differentiation of this first order with respect to y. So it will be del y of del u by del x. Del y of this whole thing. So here you have to consider this y square minus x square as single y, because this is a partial derivative with respect to y. So del y of 1 by root over y, that means y to the power minus half. So it will be minus half into this whole thing is y to the power minus half minus 1, so minus 3 by 2. And this is not simply y, so you have to perform this differentiation del y of what? Y square minus x square. This will give you 2y, because this term is constant with respect to y. So 2y here, and there was minus half. So 2 to cancel out, ultimately you are getting minus y divided by this. Now compare the two results. Yes, they are same, minus y by this, and here also it is minus y by this. So these two results are same. They are same. So the next partial derivatives are equal. Now, there is a function in which there are three variables. Just a minute. So, can you see the screen? Can you
Yes,
see
ma'am.
the screen?
Yes,
Okay.
ma'am.
Okay, so this is what? W equal to 4x minus 3y plus 2z whole to the power 5. And you have to find this. This is a second order derivative, del square w by del x del y. And what is it? Del cube w by del x del y del z. So here at first you have to perform the derivative with respect to y, then with respect to x. And here at first with respect to z, then with respect to y, and then with respect to x. And in the third one, it is of fourth order. It is of fourth order, at first with respect to x, then with respect to y, and then with respect to z twice. So I am showing you the second and third one. What is happening here? Just a minute. Okay. I'm doing the second one at first. So this is wxyz equal to 4x minus 3y plus 2z whole to the power 5. So at first, in the second one, what is it in the second one? At first with respect to z, then with respect to y, then with respect to x. Remember, when the notation is in the del form, if the notation is in the del form, then you have to start from the right to the left. Remember, from the right to the left, if the notation is in del form. So at first with respect to z, then with respect to y, then with respect to x. So at first with respect to z. So del z of this whole thing. So here this inner part should be considered as your z, because your partial derivative is with respect to z. So this should be now what? Z to the power 5. So it will be what? Z to the power 5 means it will give you 5 Z to the power 4. So this 5 into this whole thing is your Z, Z to the power 4. Now, this is not simply Z. So you have to perform the partial differentiation of this whole thing with respect to z. So it will be multiplied by del z of this whole thing. So there are combination of three terms. This should be treated as a constant. This should be treated as a constant. So only term is 2z. And after differentiating this 2z with respect to z, it will be simply 2. So 2 into this 5 will be 10. 10 into this whole thing whole to the power 4. Now with respect to y, differentiate this with respect to y. So now you are getting del square w by del y del z. So del y of del w by del z. So del y of this whole thing. Now what is the differentiation? It is with respect to y. So how shall we consider this function? Please tell me. This whole thing should be considered as what?
X. X to the
As
power 4 ধরবো।
as what?
Y to the power
Y.
4
Y.
Yes. Why? Because your differentiation is with respect to y. Remember, if it is differentiation with respect to y, then the whole thing should be considered as y. So it is 10 is a constant, so it can be taken outside. So now it is y to the power 4. Y to the power 4 gives you 4y cubed. So this 10 into 4 into this y whole to the power 3. And you have to differentiate it again with respect to y. So it should be multiplied by del y of this 4x minus 3y plus 2z. And you see this is constant. This z term is also constant. So here remains what? Only minus 3y. And after differentiating, it will give you simply minus 3. So this 40 into minus 3, it will be minus 120 into this whole thing whole to the power 3. Now again, you have to differentiate this with respect to x. So it del cube by del x, del y, del z, it means del x of this thing. So that means del x of this whole thing. So del x of minus 120 into this. So this is a constant, you can take it outside. And now the differentiation is with respect to x. So you have to consider this whole thing what?
X as X.
X cube. That means it will give you 3x squared. So this minus 120 into 3 into this whole thing power 2. But this is not simply x, so you have to differentiate it again with respect to x and then multiply. So this whole thing multiplied by del x of this 4x minus 3y plus 2z. Now it is with respect to x, so this term is a constant, this term is a constant, so only 4x, that means it is giving you 4. So just multiply this whole thing by 4, it will give you minus 1440 into this whole thing to the power 2. Okay, now the third one, what was it in the third one? It is fourth order derivative, at first with respect to x, then with respect to y. Then with respect to z twice. So we start from x, then y, then z. Okay, this was number 3. So in similar way, at first we find del w by del x, so del x of whole thing. So this should be considered as x. So that means x to the power 5. So it should be 5x to the power 4 into del x of this whole thing. And this y term constant, z term constant, so just 4. So this 4 should be multiplied with this 5, so 20 into this. And then with respect to y, differentiate this with respect to y. So del y of del w by del x. So del y of this whole thing. This 20 is a constant, so take it to the outside of the derivative. 20 into what? Del y of this whole thing. So consider this whole thing as y to the power 4. That means after differentiation with respect to y, it will give you 4y cube. So 4 into 20 is 80, and this whole thing to the power 3. Okay, but you have to multiply it with what? Del y of this whole thing, because it is not simply y, it is 4x minus 3y plus 2z. So with respect to y, differentiation is with respect to y. So this x term is a constant, this z term is a constant, only minus 3y, and after differentiation with respect to y, it will give you just minus 3. So 80 into minus 3, it will be minus 240 into this whole thing to the power 3. Okay, Next comes third order derivative of this with respect to what? Z. So you have to differentiate this second order derivative with respect to Z. So del del Z of this, that means del del Z of this. So this minus 240 should be taken outside, and del del Z of this whole thing, power 3, so the inner part should be considered as Z. So Z cube gives you what? 3Z square. So 3 into minus 240 gives you minus 720, and this whole thing to the power 2. So this again should be multiplied by del del Z of this inner part. So in this case, x term is a constant, y term is a constant, only 2z. So after differentiation with respect to z, it will be give you just 2. So minus 720 into 2 will be this, into this power 2. Okay, it was fourth order derivative. Fourth order derivative. So you have to perform the differentiation of the previous one with respect to z again, because it is z square. So del del z of this whole thing. That means del del z of this whole thing. So here minus 1440 should be taken outside, and it is del del z of this thing. So this inner part should be considered as z, that means z square. Z square, after performing differentiation with respect to z, it will give you 2z. So this thing multiplied by 2 into 2x, 2z, yes, 2z. 2 into z, your z means this inner part. And again, you have to multiply it by the partial or derivative del del z of this inner part. So x term constant, y term constant, it gives you only 2. So again another 2. So 4 into this thing will give you this. So this is the result. Now you see the partial derivatives are given with this subscript notation. With this subscript notation. So f of xyz equal to this. This is a polynomial, so it will be very easy for us to perform the differentiation. So we will start from this. I'm not doing this whole thing. I'm starting with this 6. So the first one is fxxy. Can you please tell me from what we shall start? Please answer me.
X, f of x.
Yes. At first with respect to x, from the left to the right. At first with respect to x, then again with respect to x, then with respect to y. And here, please tell me.
First Z,
At first z, then
Y, then
y,
X.
then x, right. Here at first x, then y, then z. So I'm starting with 4 here. Oh no, I'm starting with 6. Yes. I'm starting with this. F of xyz. So at first fx, it means del del x of f. So del del x of this whole thing. So you see this term does not contain any x, so it will give you 0. Here y to the power 5 and z to the power z will be, z to the power 7 will be constant, and for this x cube with respect to x, it will give you 3x square. So ultimately this term will give you 3x square y to the power 5 z to the power 7. And when you perform the differentiation with respect to x, this y square is a constant, and del del x of x is just 1. So there will be only y square. Now fxx, that means you have to find fx with respect to x. Differentiate fx with respect to x. That means del del x of fx. And del del x of fx means del del x of this thing. So here again this term is a constant. Y square is a constant, there is no x here. And the x term is simply x square. And the constant factors are 3, y to the power 5, z to the power 7. And for this x square, you are getting 2x. So it will be 6x, y to the power 5, z to the power 7. Yes. Now, fxxy. So you have to perform the partial differentiation of fxx with respect to y. It means del del y of fxx. Del del y of fxx. And fxx means this. So del del y of this whole thing. So again, the constant factors are 6, y to the power 5, z to the power 7. And del Okay, I'm sorry, it was with respect to y. So these are constant factors, 6, x, and z to the power 7. These are constant factors. So the factor to be concerned should be y to the power 5, which will give you 5y to the power 4. So 5 into 6, it means 30 x y to the power 4, z to the power 7. Now the next one. So finally, you have to find this f, z, y, x. So at first, you have to perform with respect to z, then with respect to y, then with respect to x. So at first, we find fz. Fz means del f by del z. That means del z of this whole thing. So which term is constant? Yes, xy squared. This will give you 0. And here, x cube y to the power 5 is a constant factor, and the z to the power 7 with respect to z, it will give you 7z to the power 6. So ultimately, this term will give you 7x cube y to the power 5 z to the power 6. And this is 0. This will give you 0. And here, it will just give you y cube because del z of z is 1. Now we find zy. That means differentiate this fz with respect to y. Differentiate this fz with respect to y. So it means del y of f of z. Del y of f of z means del y of this thing. So both the terms contain y. So here 7x cubed z to the power 6 will be constant. And for this constant factor, and for this y to the power 5, it will give you 5y to the power 4. So ultimately, 5 into 7 is 35. 35 x cubed y to the power 4 z to the power 6. And for y cube, it will be 3y squared. Okay. And then with respect to x, yes, z and y is performed. So it will be performed that partial differentiation of f z y with respect to x. So differentiation of f z y with respect to x. That means del x of f z y. So del x of this whole thing. You see the second term does not contain any x, so it will give you 0. And here 35 y to the power 4 z to the power 6. These are constant factors, and x cube gives you 3x squared. So 35 into 3 gives you 105 x squared y to the power 4 z to the power 6. And what is it in the next one? So I think I will do the last one now. Yes, the last one is f x y z. So at first with respect to x, then with respect to y, then with respect to z. Okay. So this is your last one. So at first fz means del z of f, del f by del z, del z of f. This is yours. F with respect to z. So this term will be constant for us. And here x cube y to the power 5 is constant factor. For this z to the power 7, you will get 7z to the power 6. So ultimately this term, and this will give you 0, and this will give you just y cube. Okay, for the next one, it will be with respect to y. Perform the partial differentiation of this fz with respect to y. That means del y of f of z. So del y of this whole thing. Both the terms contain y. So for the first term, 7x cube z to the power 6. These are constant factors, and for y to the power 5, you will get 5y to the power 4. So 35 x cube y to the power 4 into z to the power 6. And for this y cube, it will be 3y squared because the differentiation is with respect to y. Okay, then the last one with respect to x. So it will be partial differentiation of this f of zy with respect to x. Okay, I think we have done this one. I'm sorry. I should have looked into this. At first with respect to x, then with respect to y, then with respect to z. So fx. So y to the power 5, z to the power 7 constant, this will give you 3x square. So 3x square, y to the power 5, z to the power 7. This will give you just y square, and this will give you 0. Okay, next, fxy, that means differentiation of fx with respect to y. So del y of fx. Okay, I think I have to give your attendance. Okay, let us complete this file, then I will take the attendance. So here, del y of fx. So your fx is this, del y. So both the terms contain y. So this term will give you what? Y to the power 5 will give you 5, y to the power 4. That means 15 x square, y to the power 4, z to the power 7 plus 2y. And then finally, with respect to z. So this term will give you 0. And for with respect to z, it will give you 7 into 15, 105. X square, y to the power 4 into z to the power 6. So here we see that the last two derivatives are equal. F z y x and f x y z, they are same. It happens for this particular function, but it is not always same. It is not always same. So you see, your exercise was 13.3. Your exercise is 13.3, and for the previous lecture, the question number is this for you. 3 up to 6, same exercise. 3 up to 6, 17 up to 22, 23 up to 27, 30 up to 32, 35 up to 37, 39 up to 42. And for today's lecture, 73, 74, 76 up to 81, 85 up to 91, and 94. Okay, so this
13.3 নাকি 13.5 হবে?
13, 13, 1, 3, 13, 1,
Yes,
3.
miss. 13.5 হবে না? Like course outline দেওয়া 13.5.
I think 13.5 is chain rule. We will start this chain rule today. This exercise is 13.3, not 13.5. 13.5 will be for the chain rule of partial derivatives. This is okay, 13.3. Okay, I will check the course outline. So let me stop the sharing for this moment.
13.3 means course outline 13.3 দেখাচ্ছে partial derivatives আর multiple chain rule in intergrade
13.5.
এটা 13.5.
Right, yes. So this is okay. This is perfectly okay. Okay, just a minute. Now, please tell me, can you see the screen? The chain rule for derivatives.
Yes, miss.
Chain rule for derivatives. This is from section 13.5. Okay, the chain rule for derivatives. Let us start this one today. It may not be complete today, but let us start it. So if y is a differentiable, okay, at first let us consider the chain rule in two dimension. In two dimension, when we have only two variables, one is independent, x is independent, and y is dependent on x. So if y is a differentiable function of x only, and x is again a differentiable function of t. That means y is a function of x and x is again a function of t. Then you can perform the ordinary differentiation dy by dt like this. This was our formula in our ordinary differentiation. If y is a function of x and x is a function of t, okay, in that case dy by dt was equal to dy by dx into dx by dt. The same idea will be here for the chain rule for the functions of two independent variables. Suppose that z equal to f of x, y. You see here x and y are the independent variables and z is the dependent variable, where z is a function of x and y. Okay, so z equal to f of x, y is a function of two variables x and y. And suppose that here, suppose that x and y, both of them are functions of another variable, say t. That means x is a function of t. It can be written like this: x is a function of t and y is also a function of t. In that case, ultimately z can be expressed as a function of t, because z equal to f of x, y, that means z equal to f of x of t, y of t. So what does it mean? Ultimately, the total whole function can be expressed as a function of t only. So you can perform, since there is only single variable t, so you can perform the ordinary differentiation dz by dt. Because ultimately, if you write x as a function of t and y as a function of t, then this z will be can be expressed as a function of t only, and it can be represented by dz by dt. And there is a theorem which involves the chain rule for the derivative for this dz by dt. And this is the theorem. If x is a function of t, y is a function of t, are differentiable, if these two functions are differentiable at the point t, at any point t, and if z equal to f of xy is differentiable at the point xy. That means if you see now, if it is given in this form, you can perform the partial differentiation del z by del x and del z by del y. Okay, this sentence means that thing. If z equal to f of xy is differentiable at xy, it means if del z by del x and del z by del y exist, in that case, z equal to f of xt yt is differentiable at t, which is given by this chain rule. You see, dz by dt, this total derivative dz by dt will be equal to del z by del x into dx by dt plus, here there are two variables, not only one. So it will be del z by del y into dy by dt. So you just consider an extension of this chain rule. Just consider an extension of this chain rule. Here, y was a function of x only and x was a function of t. So in the independent variable, there was only one. It was only x. So there is only one term here. dy by dx into dx by dt. This is dy by dx because y is a function of x only. There is no other variable. That's why it is dy by dx. But here z is a function of x and y. So when you perform this differentiation of z with respect to x, it must be partial differentiation. So it will be del z by del x into, you have to multiply it by the derivative of x with respect to t. Now x is a function of only t. So this can be written like this, dx by dt. but there is another variable, so plus another term should be there, del z by del y into dy by dt. So this is the chain rule for this ordinary differentiation, dz by dt. Now, instead of these two variable, instead of this only one variable t, if you have two variable, that means if x is a function, okay, okay, before going to the two variables, here we have considered w as a function of x, y, and z. So in that case, there will be three terms. So here z was a function of x and x and y was a function of t. But if you have a function, say w is a function of x, y, and z, in that case, dw by dt, there will be three terms. For the three variables, there will be three terms. So it will be it will be del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. Yes, because in place of two variables x and y, now you have three variables x, y, z, and the total function is denoted by w. So dw by dt, just extend this formula uh, into three terms, because there is one more variable here. So dw by dt will be del w by del x into dx by dt plus del w by del y into dy dt plus del w by del z into dz by dt. Okay, if there are three independent variables. Now, chain rule for the partial derivatives. This was for the total derivative, dw by dt, because ultimately w can be expressed as a function of single variable t. Here also, it can be expressed as a single variable, as a function of single variable t. So that's why dz by dt and here dw by dt. Now, if the variables x and y are functions of two variables again, so this is another theorem. Suppose that x equal to x of uv and y equal to y of uv. That means, you see, x is a function of u and v. For x, this u and v are the two independent variables. X is a function of these two independent variables and y is again a function of these two independent variables. So are functions of the variables u and v, and that they have the first order derivative. That means del x by del u, del x by del v, del y by del u, and del y by del v exist at any point uv. Now, if x z equal to x, function of x and y, is differentiable at xy, it means if del z by del x and del z by del y exist, then this z can be expressed as a function of u and v, because originally z was a function of x and y, but x and y are again functions of u and v. So ultimately this z can be expressed as a function of u and v. So you can perform the partial differentiation del z by del u and del z by del v. And there is a formula for this. These two cannot be total derivative because now z is a function of u and v. But in the previous two cases, z and w was function of only one variable t. But here this z is a function of two variables u and v. And this is the formula. This is the formula, del z by del u equal to del z by del x into del x by del u. You see, you have to perform the differentiation like this. Del z by del u will be equal to del z by del x into del x by del u plus del z by del y into del y by del u. Okay, if it is with respect to u. And if it is with respect to v, then all the derivatives of x and y should be performed with respect to v. So del z by del v will be equal to del z by del x into del x by del v plus del z by del y into del y by del v. Okay. Again, if you have three variables x, y, z in place of x and y, in place of x and y, if you have three variables x, y, and z, and if there is a function omega, which is a function of x, y, and z, and if each of these x, y, and z are functions of u and v, then you can find the partial derivatives del w by del u and del w by del v. There will be three terms. In place of two, there will be three terms. So del w by del u, del w by del u, it will be equal to del w by del x into del x by del u plus del w by del y into del y by del u plus del w by del z into del z by del u. And when you find del w by del v, it will be del w by del v will be equal to del w by del x into del x by del v plus del w by del y into del y by del v plus del w by del z into del z by del v. So you see, these are just the extensions. The main idea is same. If the number of variables increases, the number of terms increases. Okay. So these are the main things. Now let us do, okay, we can perform only one math here. So let us do it. Use appropriate chain rule to find dw by dt. So this is a total derivative for the following functions and verify the result by differentiating w directly with respect to t. Okay, here I have, let me show the first one. Let me show the first one at first. Okay, I think it will be problematic. Let us do the second one. It will take time to explain. So I'm doing the second one. You see w x y z equal to 5x square y cube z to the power 4, where you see x is a function of t only, x equal to t square, y is a function of t only, y equal to t cube, and z is the function of t only, it is t to the power 4. So you can easily write down dw by dt. dw by dt. Which formula can we use here? Which chain formula? Which one? You see here are three variables x, y, z, and all of them are functions of t only. So here we will have to use this one. This one. There are three variables x, y, z. So you have to use this one. dw by dt equal to this. Number 2. So it is in the next page. In this page. This was our math. So by chain rule, this dw by dt will be equal to del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. So this is the expression for dw by dt. Now let us find all the derivatives. At first you find del w by del x, del w by del y, del w by del z. So this is your w. So del w by del x will be del x of this. By now, you know how to perform this partial differentiation. 5y cube z to the power 4 will be constant, and for this x square, you will get simply 2x. So this is your result. Next, del w by del y. So you have to perform the differentiation with respect to y. So 5x square z to the power 4 should be multiplied by 3y square. This is the result. And then del w by del z. So these 5x square y cube are constant. From z to the power 4, you will get 4z cube. So 20x square y cube z cube. Okay. Now let us find the value of dx by dt, dy by dt, and dz by dt. So what is your x? X is t square. So dx by dt will be 2t. Your y is t cube, so dy by dt will be 3t square. What is z? Z equal to t to the power 4. So dz by dt will be 4t cube. So just use these results in your formula here. So dw by dt will be equal to del w by del x means this into dx by dt means t square. And del w by del y equal to this. So this should be multiplied by dy dt means 3t square. Del W by del Z is this. This should be multiplied by dz by dt. This means 4tq. So now you have to express the whole thing in terms of t. It is possible here because you know all the values of x. X is t square, y is t cube, and z is t to the power 4. So just do the algebra. Just do the algebra. X means t square, y means t cube, so t cube whole cube. Z means t to the power 4, so t to the power 4 whole to the power 4 into 2t. So here x square means t square whole square. Y means t cube, so t cube whole square. Z means t to the power 4, so t to the power 4 whole square into 3t square. And for the last one, it will be t square whole square, t cube whole cube, t to the power 4 whole cube into 4t cube. And ultimately you will see that in all the terms, the power of t will be t to the power 28. The first term gives you 20 t to the power 28. The second term will give you 45 t to the power 28. And the third term will give you 80 t to the power 28. After adding, you will get this result. And your question was, verify this result. Verify this result by performing the differentiation directly. Verify the result by differentiating W directly with respect to, that means you have to express at first express W in terms of T and then perform the ordinary differentiation. Okay, it is done here. This is our function W x y z equal to this. So here you just put down the values of x, y, and z. So t square whole square, t cube whole cube, t to the power 4 whole to the power 4. So 16 plus 9 is 25, 25 plus 4 is 29. So ultimately it gives you 5 to t to the power 29. You see, w is a function of t only. So you can easily find dw by dt, which will be d dt of this thing. So 5 into 29 into t to the power 28. So 145. So you see, you are getting the same result. 145 t to the power 28, 145 t to the power 28. So
না হলে তো হচ্ছে প্রুভ হয় না, যদি সেম না হয় তো
definitely it will be same. It will be same because here you have done the total derivative using this chain rule. dw by dt is expressed in this form using the chain rule. So by performing this dw by dt using this chain rule, it must be the same thing. If you perform the differentiation directly, expressing this w in terms of t and then performing the differentiation to ordinary differentiation dw by dt, the results must be same. If you do not have the same result, that means you have done some mistake somewhere. There is some mistake somewhere. Is that clear?
yes miss.
Okay, so we do not have time, so I should end our class here today. So we will start from this chain rule, this file. We will start with this file again in our next class.
Miss, can you please upload both the files together?
Sorry?
Miss,
Sorry?
can you please upload both the files together?
Today I will upload the files, yes. Do you want this file also?
Yes, miss.
Okay, I will upload all these files, all the two files, yes. The first one was higher order partial derivatives, and this one is chain rule for derivatives. Okay, I will upload both the files. So
মিস 12:13 আমাদের অ্যাটেন্ডেন্সটা মেবি হচ্ছে
okay, I have submitted your attendance.
ওকে মিস
I have submitted already. Today I have submitted already. In the last class, it was late. We were late. That's why it was not accepted. But your attendance was given because I have taken it in our IRAS. In the IRAS. Okay. So let me end our class here.
মিস রেকর্ডিংটা অফ করে দিলে ভালো হবে।
হ্যাঁ হ্যাঁ হ্যাঁ